Hi, my name is Patricia Miranda, and this is my presentation on metacognition. Metacognition is a monitoring and reflecting on one's current or recent thoughts. Students reach metacognition when they are performing problem-solving activities. They use the skills that they learn to manage their thinking strategies in order to accomplish the task. So, knowing these things, I started to think about how I use metacognition strategies in my classroom. I teach science, and teaching through the STEM framework, we're really trying to incorporate content from all the different subject content areas in one class. So the students are really learning math skills in their math classroom, they're learning ELA skills in their ELA classroom, but when they come to science, they're putting them all together. So the strategies that they use to make a graph is directly something that they can use in science when we do data analysis, or for ELA when they're writing their observations. And then on top of all of those things, we use a problem strategy where we try to find a problem that's happening in the real world, whether it's in our community or in the state or in the country, and we work in groups to find solutions. So as the students are able to work in groups, they start to see, well, one person's better at using the math strategy, or another person's better at doing the writing portion of it. And they're really learning from each other because they're not just depending on maybe what some of their weaknesses, or they're just not reliant on something that they're good at, because they're all experiencing a piece of each thing. So this is a really big part of the STEM framework, because the students are not only incorporating different strategies from different content areas, they're also really peer focused, and like the collaboration plays such a huge role in how they learn and what they're learning. And it's not really about teacher-centered where I'm presenting them the information. Also, with project-based learning, they get to use different intelligences to showcase these strategies, and the students are just getting a more meaningful understanding of the big idea that we're trying to learn. Collaboration element is present throughout the projects, and of course then at the end, the culminating activity is one where they present their understandings. And so many times I have students that are able to do presentations that they may not have thought about doing, that they wouldn't have reached on their own. So they get so much more out of working together. And I've also seen students who like maybe did not have any success in certain areas being able to progress because of the help of their peers. I also think it also helps with the motivation, because the students are more engaged, and being able to not rely on me as a teacher makes it more meaningful for them, because suddenly they're not, upset for not being able to get it. They can work through it on their own with the help of their peers rather than reaching out to me. So I think for me, as an example, and in my school, this is something that we do in all age areas. But after reading this chapter, it's more and more clear to me that this is metacognition, opposed to, it's really just giving a label to what we've always been doing. And I think in science, especially in STEM, like it's really just aligning itself with that, metacognitive strategies.